Okay, so this is number 81A. What volume of 0.115 molar HCl04 right here solution is needed to neutralize, and then it gives us some information about NaOH. Step number 1 in these solution stoichiometry is to write the balanced chemical equation. So we have HCl04, and then we're going to add that to some NaOH arrow. The H and the Na will swap positions, and we get some NaClO4, and then we get some HOH, and it's nicely balanced for us already. So step number 1's done. Step number 2, when in doubt, convert to moles. They give us 2 pieces of information about NaOH. So take those 2 pieces of information, and knowing the molarity triangle, if I know the molarity and if I know the volume, then I can find the moles. So step number 2, the moles are equal to the molarity, 0.0875 molarity, times the liters, and make sure you go from milliliters to liters by going 3 to the left. So 1, 2, 3, so 0.050 liters. Multiply those 2 together, and that will give me my moles of NaOH solution. So I'll just write down NaOH right here. Since I know it's moles of NaOH, I'll put a multiply sign in a line, and I'll go right to step 3, which is the mole to mole ratio. So now I'll put moles of NaOH in a position where it's going to cancel, and then I'll put moles of my desired units right up here on the top, and I go back and reread the question, and it asks for a volume of HClO4. So I'm going to put HClO4 up here on the top because that's the thing that I want to know. And it's a really nice ratio right now. It's a 1-to-1 ratio for those two. And then I'm on to step number 4 to convert to the asked for units. And in this case, they want to know volume. So once again, I'll use my molarity triangle, cover up liters with my finger, and I know that it equals moles divided by molarity. If I push the buttons on my calculator right now, I have moles of HClO4. And if I want to know volume, volume is equal to moles divided by the molarity. So this answer right here would go on the top. And then I divide it by the molarity, which the molarity right here is 0.115. I get that right from the problem right here. So let's try it on a calculator, and let's see what we end up with. So 0.0875 times 0.05, enter, times 1 divided by 1, and then we're going to take that number and we're going to divide that by 0.115, and enter, and I end up with a volume of 0.038 liters, which is 38 milliliters to 2 significant digits. All right, letter B. What volume of 0.12 molar HCl is needed to neutralize 2.87 grams of MgOH2? Step number 1, write the balanced chemical equation. So we're given MgOH2, and then that is going to react with HCl. Arrow, take the magnesium and the hydrogen and swap them. So then you end up with the magnesium with the chlorine. Make sure that you balance the +2 of the magnesium with the -1 of the chlorine, so that means it means MgCl2, and then the H goes with the OH, so you end up with HOH over here, and now you have to balance the equation. 2 here for the chlorines, and then I'll need a 2 here for 4 hydrogens. 2 plus 2 is 4 hydrogens, 2 oxygens, 2 oxygens, it's balanced. Step number 2, when in doubt, convert to moles. So now I need to be good at looking, good looking and good at looking at the information that they give me. What information do they give me that can convert to moles? Well, they give me 2.87 grams of the MgOH2, and you know how to go from moles to grams. If you forgot, look on the inside of your periodic table to go from grams to moles. It's 1 mole on the top, molar mass on the bottom. Multiply sign, put a line, put grams of MgOH2 here in a position where it's going to cancel. Moles of MgOH2 as your new set of units. And now you have to add that up on the periodic table. Magnesium is 24.3, and oxygen, of course, is 16, and there's 2 of them. And then hydrogen is 1, so there's 2 of those as well, so we'll add by 2. And then we get 58.3 grams in 1 mole of the magnesium hydroxide. That's step number 2, converting to moles. Now step number 3, use the mole-to-mole ratio. So put another multiply sign in a line, put the units that you have in a position where it's going to cancel. So MgOH2 goes in a position where it's going to cancel. In my desired units, I go back and reread the problem. What volume of Hickel? Okay, Hickel is the thing that I want to know, so I put that right up here. Now this is a mole-to-mole ratio, or a fraction, and I get it from this balanced equation. A 2 in front of the HCl, a 1 in front of the MgOH2. Now if I stopped right there, I'd have my moles of Hickel. But I go back to the question and read what do they want to know, what units do I want to convert to, if any. It says what volume of HCl is needed. So what I'm looking for is volume right here. I'm looking for liters, so I'm going to have to take my moles and divide it by my molarity. If I stop right here, I said I'd have moles of HCl, and then I'd take that and divide that by the molarity, and it tells me the molarity in the question is 0.128 molar. Okay, let's try this on the calculator and get it into here, and we'll get our final answer. 2.87 divided by 58.3, enter, times 2, enter, and then we'll take that answer, which is 0.09845, carry a whole bunch of decimals right now, and then divide that by 0.128, enter, and I got 0.7, well, rounding up 780 approximately, and that would be in liters, which if it wanted to know milliliters, it'd be 3 to the right, so 780 milliliters.